The functional group in the reactant is ketone. Ketone treated with NH2OH. So it is a hydroxylamine. Hydroxylamine in the presence of slightly acidic medium. So dehydration takes place and the corresponding product will be formed. It is what we call oxime. Oxime treated with H2SO4. Suppose it is oxime. When it is treated with H plus or Lewis acid PCl5. So here it loses OH minus. The anti-group will migrate and it forms corresponding carbocation. Now this carbocation react with the OH minus and form corresponding tautomeric compound. Now it undergo tautomerization, finally converts into amide. So this entire reaction is known as Beckmann rearrangement. So here the group opposite to OH group will migrate. So in this case also OH anti-group and opposite group, it is opposite group. So it will migrate like this. Therefore corresponding structure, it is migrated. Now here this carbon gets double bond O. It is called caprolactam. Now the caprolactam react with strong reducing agent lithium aluminum hydride. So this amide group will be reduced to corresponding amine. So finally we are getting secondary amine. The reactant is aniline or benzenamine. When it is treated with acetic anhydride, CH3, C double bond O, C double bond O, CH3. Acetic anhydride. It is a leaving group part and it is a nucleophile. So nucleophilic substitution takes place. SN2 reaction takes place and the corresponding product is NH, C double bond O, CH3. So this reaction is N-acylation and the product is known as acetanilide. Now it is treated with Br2 in the presence of acetic acid. Br2 and acidic medium. So here it produces electrophile Br+. And it is because of lone pair, it is a OP directing. Therefore the corresponding product is ortho position electrophile Br plus para position electrophile Br plus. Ortho and para. Now it is treated with NaOH, H2O, heat. So this is a hydrolysis condition. This amide undergo hydrolysis. And we get corresponding product like this. NH2, Br and the leaving group is CH3COOH. NH2 para position Br CH3COOH. The first reaction is N-acylation, second reaction is electrophilic aromatic substitution, and third reaction is hydrolysis. Para-aminophenol treated with acetyl chloride CH3COCl. It is simply ACCl. So here leaving group is present. It is a nucleophile. It is also nucleophile, and we know that nitrogen is stronger nucleophile because of less electronegativity. Therefore corresponding N-acylation takes place. Now it is treated with KOH and methyl iodide. So KOH can act as base as well as nucleophile. So here it is a amide functional group. Amide functional group is neutral with respect to water, but phenol is acidic with respect to water. Therefore KOH remove the proton and form corresponding O minus phenoxide derivative. It is treated with methyl iodide. So iodine is a leaving group. And N lone pair can attack. O negative charge also can attack. Therefore the corresponding product is, when compared to N lone pair, O negative is stronger nucleophile. Therefore it forms corresponding OCH3. Now it is treated with lithium aluminum hydride. Lithium aluminum hydride is a strong reducing agent. It reduces amide functional group to corresponding amine. The first reaction is N-acylation, second reaction is O-alkylation, and third reaction is reduction of amide. The reactant is Michael compound. When alkene connected to ketone, that is Michael compound. So here Michael addition possible like this. It is also called 1,4 addition. Now if you observe the product, one more Michael addition possible. Finally we get corresponding cyclic compound. Now it is treated with glycol type compound, vicinal diol glycols, in the presence of H+. So we know that when ketone reacts with glycol type compound, we have to remove the water and form corresponding acetal. Form corresponding acetal. And here stereochemistry does not change. So this function group is known as ketol, also known as acetal. Now it is treated with 1 equivalent methyl iodide. So here iodine is a leaving group. Therefore nitrogen lone pair, oxygen lone pair. So here if you compare the lone pairs, nitrogen lone pair is a stronger nucleophile. Therefore SN2 reaction takes place SN2 reaction takes place and the corresponding product is benzene, methyl plus I minus and corresponding ketone. It is our final product. So first reaction is 2 times Michael addition, second reaction is acetal formation, and third reaction is SN2 type of reaction. Benzene sulfonic acid treated with fused NaOH. So this reaction is AR-SN2 reaction or SNAR reaction. So in place of SO3H, we will write OH minus. It is AR-SN2 mechanism. Since it is a basic medium, initially it forms phenoxide. After that we are adding H3O plus. Finally it converts into corresponding phenol. When phenol treated with dilute HNO3, we get electrophile NO2 plus and OH is OP directing. Therefore, electrophilic aromatic substitution takes place. We get corresponding O-nitrophenol and P-nitrophenol. O-nitrophenol and P-nitrophenol. And here O-nitrophenol is major product because of intramolecular H bonding, and O-nitrophenol is also steam volatile and less soluble in water when compared to para. Less soluble in water, boiling point also less, vapor pressure high, and acidic strength also less when compared to para. Now this is treated with COHCl AlCl3. So it is a CO structure. When it reacts with H plus, it produces corresponding HC triple bond O plus. Now from this we write electrophile HCO plus. So this reaction is Getterman-Koch reaction. This reaction is Getterman-Koch reaction. Therefore, here suppose if it is reacting, OH is activating, NO2 is deactivating with respect to OH, ortho, para. So corresponding product is with respect to OH, para product is major. It is our electrophile. So this electrophile attack majorly at para position. Similarly, this electrophile also attack at ortho position. Therefore, the corresponding product is like this. The first reaction AR-SN2 mechanism, second reaction nitration of phenol EAS, third reaction Getterman-Koch reaction EAS. The reactant is benzene diazoning chloride. It is treated with HBF4. So it forms corresponding salt N2 plus BF4 minus, para position SO3H. It is treated with copper and NaNO2. So here in the presence of copper, it loses N2 gas and NO2 minus attack. Therefore, the corresponding product is nitro group and para position SO3H. Whenever copper is present in the benzene diazonic compounds, it undergo free radical substitution. Now it is treated with dilute H plus. So whenever we see sulfonic acid and dilute H plus, desulfonation takes place. Desulfonation takes place and the corresponding product is NO2 and para position hydrogen. So it is also simply electrophilic aromatic substitution. First reaction is just salt formation. Second reaction is FRS mechanism. Third reaction is desulfonation. Aniline or benzenamine treated with concentrated sulfuric acid. So it is a base, it is an acid. Initially, acid-base reaction takes place. It forms corresponding NH3 plus and HSO4 minus. which on heating loses H2O and form corresponding product NSO3H, which on further heating finally converts into NH2 para position SO3H. So here this is electrophile. Electrophile is migrated to para position. This compound name is sulfonilic acid. Sulfonilic acid. It is treated with bromine water. So when aniline treated with bromine water, we get corresponding ortho position electrophile Br, para position electrophile Br, even SO3H also. Since bromine water is acidic medium, so desulfonation takes place and Br plus attack. Since it is acidic medium, desulfonation takes place and electrophile Br plus attack. So this is our final compound. Now it is treated with HNO2 and heat is given. So when in the presence of HNO2, it produces electrophile NO plus. Now NH2 react with NO plus. This reaction is known as diazotization. Diazotization. Therefore, the corresponding product is NH2 converted to N2 plus. Since heat is given, so it reacts with water. While heating, it follows ARSNO mechanism. It loses N2 gas, form carbocation, and this carbocation react with water. Therefore, finally we get corresponding 2,4,6 tribromophenol. 2,4,6 tribromophenol. It is a white PPT, that means water insoluble. The reactant is succinimide. Succinimide, imide functional group. When it is treated with Br2NaOH, this reaction is known as Hofmann bromamide reaction. Hofmann bromamide reaction. So the basic mechanism is when imide reactant treated with Br2 and OH minus, in the presence of OH minus, it loses proton. N minus will form. N minus react with Br2 and form corresponding N-bromosuccinimide. Corresponding N-bromosuccinimide. Now it react with OH minus, nucleophile attack, leaving will leave, converts into carboxylic acid and CO N minus Br. Whenever we see CO N minus Br, it immediately converts into isocyanate NCO. Isocyanate NCO. Now this isocyanate undergo hydrolysis. Finally we get corresponding product like this. So this is a Hofmann bromamide reaction. Hofmann bromide reaction. Therefore here we are getting the corresponding compound like this. Hofmann bromamide reaction. Now it is treated with HNO2. So when NH2 group treated with HNO2, HNO2 produces electrophile NO plus, N lone pair attack with NO plus. Finally it converts into diazonim salt, and aliphatic diazonim salt is unstable since it is primary. So water attack, leaving group will leave. So we get corresponding beta hydroxy acid. Beta hydroxy acid. It is a second reaction. When beta hydroxy acid is heated, alpha beta hydroxy acid is heated, undergo dehydration and form corresponding compound. So it is a acrylic acid. Acrylic acid. Beta hydroxy acid when heated undergo dehydration and form corresponding acrylic acid. The first reaction is Hoffman bromamide reaction. Second reaction is amine reaction with HNO2 gives corresponding alcohol. Third reaction is heating effect of beta hydroxy acid. The reactant has two functional groups, phenol and aniline. Phenol and aniline. It is treated with electrophile benzene diazonium in the presence of basic medium. So in the presence of basic medium, coupling reaction takes place with respect to OH. So it is simply coupling reaction, and in basic medium with respect to OH, coupling reaction takes place. Para position is blocked, therefore corresponding ortho position our electrophile. This is again treated with benzene diazonium electrophile in the presence of base. Again coupling reaction takes place in the presence of base with respect to OH, electrophile attack. Second time coupling reaction. This is a first electrophile and it is a second electrophile because para position is blocked with NH2. Para position is blocked with NH2. Now product again treated with corresponding diazonium electrophile in acidic medium. Acidic medium coupling reaction with respect to NH2. Acidic medium coupling reaction with respect to NH2, and with respect to NH2, ortho blocked, ortho is vacant, para is blocked. Therefore there is only one possibility, para is blocked already. So with respect to NH2, ortho position electrophile. With respect to NH2, ortho position electrophile. Benzene diazonium chloride treated with H2O and heat. So of course it is a naphthalene diazonium chloride. So benzene diazonium chloride when heated with H2O and heat, it undergo AR-SN1 mechanism. In AR-SN1 mechanism, it loses leaving group, form unstable carbocation. Now it reacts with water and form corresponding phenol. Similarly in this case also AR-SN1 mechanism, in place of N2 plus nucleophile attack, and finally we get our corresponding beta naphthol. Corresponding beta naphthol. Beta naphthol treated with electrophile benzene diazonium. Electrophile benzene diazonium. So whenever beta naphthol, so whenever here beta position OP directing group is present, electrophile always prefers alpha position. Whenever in naphthalene OP directing group is present at beta position, electrophile always prefers alpha position. Therefore here the corresponding product is beta position OH and alpha position our electrophile N double bond N PH. Electrophile alpha position. Now it is heated with zinc and heat. జింక్ తో మనం హీట్ చేస్తే సో మనకి బేసిక్ రియాక్షన్ తెలుసు, ఫినాల్ కి జింక్ అండ్ హీట్ ఇస్తే కరెస్పాండింగ్ ఆన్సర్ బెంజీన్ ప్లస్ జింక్ ఆక్సైడ్. Similarly here zinc remove this oxygen and the corresponding product is like this. So it is simply reduction. Removal of oxygen is a reduction. First reaction ARSN1, second reaction coupling, third reaction reduction. The reactant has two functional groups. One is alkyl bromide, one is alcohol. It is treated with HBr. When it is treated with HBr, lone pair attract the proton and form corresponding oxonium ion. When H2O is leaving, this carbon get positive charge. When this carbon getting positive charge, bromine immediately donate its lone pair and form corresponding three-membered cyclic ring. Form corresponding three-membered cyclic ring. cyclic halogen ion, because within the molecule nucleophile is available. Now it react with Br minus. Br minus can attack at this carbon, can also attack at this carbon from the opposite to previous bromine. Therefore here Br below the plane, Br above the plane, plus Br above the plane and Br below the plane. And these two compounds are enantiomers. These two compounds are enantiomers. So this entire mechanism is neighboring group participation. That means this bromine also involved in the reaction. So neighboring group participation. Now the product is treated with the zinc. So we know the basic reaction. When dibromo compound, it is a dibromo compound, when it is heated with zinc or magnesium or I minus acetone. So zinc remove the bromine like this, anti-elimination, and form corresponding alkene. So in this case also zinc remove the corresponding halogen, and of course in this case stereo supporting also. Finally we get corresponding cycloalkene plus ZnBr2. It is an example of anti-elimination. It is an example of anti-elimination. Now it is treated with selenium, platinum, palladium, Cr2O3, Al2O3. We can also use V2O5. We can also use MO2O3. So when we are heating the compound, non-aromatic compound, treating with these kind of reagents, removal of H2 takes place. Finally we get corresponding aromatic compound. Aromatic compound. When these aromatic compounds, when we are heating in the flame, when these aromatic compounds, when we are heating in the flame, so they form sooty flame, like smoke particles. Sooty flame. So if the in the question it is mentioned as if any compound related to sooty flame, 99.99% that compound is aromatic compound. Generally we do the test in the lab to identify whether it is aromatic or not. We do the flame test. The reactant has two functional groups. One is alcohol, another one is alkene. When it is treated with the H2SO4, that means H+. So alkene react with H+ and form corresponding stable C+. Ring expansion takes place. So after ring expansion, the structure looks like this. Now lone pair participate in the resonance and we remove the proton. We get corresponding ketone like this. It is a first reaction. Now it is treated with hydrazine. N2H4 is known as hydrazine. Hydrazine. So we remove the water and form corresponding hydrazone derivative. Form corresponding hydrazone derivative. Generally, when nitrogen nucleophile is involved with the aldehyde ketone, we use a slightly acidic medium. Now it is treated with the base in solvent. It is simply base and it is a solvent, and we are heating. So here this entire reaction is Wolff-Kishner reduction. I have given part wise here. So first removal of H2O, formation of hydrogen derivative, and then elimination of these nitrogens. So finally it will give carbon ion. If no other possibility is there, acidification granted. So this is a Wolff-Kishner reduction. So this entire reaction simply Wolff-Kishner reduction. The reactant has alkene, alcohol, it is heated with concentrated H2SO4. So here what happens, lone pair attract the proton and form corresponding oxonium ion. It loses water, form corresponding carbocation, and after resonance it form corresponding carbocation like this. Now it undergo ring expansion, and form corresponding carbocation like this. Now it loses proton, from this it loses proton, and finally we get corresponding product like this. So here the product is when it is heated with the zinc, it is a hydrocarbon. When it is heated with the zinc, nothing will happen. So after KMnO4 there is no reaction. Suppose if I consider, because here mistakenly I have given the zinc, suppose zinc is not there in the question, then you can continue the question like this. Suppose question is modified like this. Now we know that when it is heated with a strong oxidizing agent, benzylic carbon having hydrogen undergo oxidation and it gives corresponding phthalic acid. But here we cannot consider phthalic acid. We have to remove the H2O and form corresponding phthalic anhydride. So how to decide whether, generally we take this carboxylic acid only. But in the given question I have mentioned insoluble in aqueous NaOH and aqueous sodium bicarbonate. This compound is soluble in aqueous NaOH and aqueous sodium bicarbonate, but this compound is insoluble. It is anhydride. Anhydride is insoluble in aqueous NaOH and aqueous sodium bicarbonate, but soluble in hot aqueous NaOH. So generally hot aqueous NaOH we have to consider ester, amide, cyanide, isocyanide and anhydride. So these functional groups are soluble in hot aqueous NaOH. The reactant has two functional groups. One is alkyl bromide and alcohol. It is treated with Ag+, AgNO3, that means Ag+. Ag+ always remove the halogen. So Ag are eliminated and form corresponding carbocation. Now it undergo ring contraction, because if this carbon get positive charge, lone pair octet is possible. Therefore the corresponding structure is after ring contraction like this. 6-membered ring contracted to 5-membered ring. Now lone pair participate in the resonance and we remove the proton. Finally the corresponding product is ketone. Now the ketone treated with Br2 and acetic acid. It is acidic medium and Br2 means Br+. So in acidic medium we are adding electrophile. To the ketone. So the corresponding answer is electrophilic aromatic substitution at alpha carbon. The tautomeric proton replaced by Br plus. Now here there is no proton here. This is the only proton which is participating in the tautomer. Therefore the corresponding tautomeric proton H plus replaced by electrophile Br plus. Replaced by electrophile Br plus. Now it is treated with mild reducing agent NaBH4 in methanol solvent. So NaBH4 is H minus. H minus is nucleophile. H minus attack, pi bond shifted. And corresponding product form like this. Now it is a O minus and it is a leaving group. So O minus attack, leaving group will leave and form corresponding epoxide. Form corresponding epoxide. So this epoxide is soluble in cold concentrated H2SO4. So cold concentrated H2SO4, we can consider alkene, we can consider alkyne, we can consider aromatic compounds, you can consider ethers, and also consider aldehydes and ketones. So generally these functional groups are soluble in cold concentrated sulfuric acid. The reactant has alcohol functional group, alkene functional group, ketone functional group, and here it is given H plus and heat. H plus and heat. And the second reaction is chloroform and KOH. So in our syllabus, chloroform and KOH means here either phenol derivative or aniline derivative are important. According to our syllabus, when chloroform and KOH is given, so the reactant should be either Riemann-Tiemann reaction type or carbyl-imine reaction type. So for carbyl-imine, nitrogen is required. Of course, we won't get any nitrogen here. Therefore, we look for the phenol type of compound. So to get phenol type of compound, so we have to do dehydration in acidic medium. So the compound undergo dehydration in acidic medium. It forms corresponding carbocation. So ring expansion takes place. So in ring expansion, we get corresponding stable carbocation. Because resonance is possible here, this resonance is possible, and the structure can be written like this: 6-membered ring, double bond O, double bond, methyl, positive, methyl. Now it undergo elimination. Finally we get corresponding product like this. It is simply dehydration. Now this proton undergo tautomerization and we get our compound phenol. We get our phenol derivative. It is a phenol. Now phenol treated with chloroform and KOH. Phenol treated with chloroform and KOH. This reaction is known as Riemann-Tiemann reaction. This reaction is known as Riemann-Tiemann reaction. Electrophile is CCl2. Electrophile is CCl2. So this is aromatic compound. Electrophile attack with respect to OH because it is a plus R group, CH3 plus H group and CH3 plus H group. We know that plus R group is strongly activating. Therefore electrophile attack with respect to OH, and with respect to OH para position is blocked, ortho and ortho. But this ortho position is more sterically hindered and this ortho position is less sterically hindered. Therefore the corresponding product is OH, methyl, methyl. This position is sterically hindered, so there is only one position left here. So it is a Riemann-Tiemann reaction. Now it is treated with Tollens reagent. Tollens reagent is NH3 to OH, otherwise AgNO3 plus ammonia. It is called ammonical silver nitrate. Ammonical silver nitrate. So Tollens reagent having the Ag plus. So Ag plus oxidizes CHO, and the corresponding answer is after acidification. Corresponding answer is after acidification COOH, and Ag plus will be reduced to Ag. It is oxidized, it is reduced, it is simply redox reaction, and also known as Tollens test. Also known as Tollens test. So this product is because of phenol positive neutral FeCl3. Phenol derivative give the positive neutral FeCl3 test, and carboxylic acid soluble in aqueous NaOH and aqueous sodium bicarbonate. Aqueous NaOH and aqueous sodium bicarbonate. The reactant has two functional groups. One is epoxide, another one is alkene. Suppose alkene react with H+. Alkene react with H+ and form corresponding stable C+. Now the stable C+ react with water and form corresponding tertiary alcohol. So it is one type of product. Another possibility is O lone pair attract the proton, form corresponding oxonium ion. Now alkene itself act as a nucleophile. Alkene attack at this carbon. Alkene attack at stable carbocation. Ring opening takes place. Therefore corresponding structure is stable C+. Now it react with water and form corresponding product like this. So among these two, it is a suitable one because we are adding 1 equivalent TSCl. If I consider the reaction here, 1 equivalent TSCl, lone pair attack on tosyl group, Cl will leave and form corresponding OTS. Now it is treated with NaN3. N3 minus is nucleophile. So nucleophile attack, ring opening takes place. Because epoxide is good leaving, if I take excess, N3 minus attack, leaving group will leave, but it is a tertiary carbon. SN2 not possible. That's why it is less favorable. So only one possibility is we can consider OH and N3 and OTS. But here Lucas immediately. So Lucas immediately means that should be tertiary alcohol. Or plus or connected carbocation. So here there is no tertiary alcohol and a plus or connected alcohol group. Therefore it cannot be the answer. That's why I am considering this one when it is treated with the TSCl. So TSCl is para-toluene sulfonyl chloride. So primary alcohol can attack, tertiary alcohol can attack, but primary alcohol less sterically hindered, tertiary alcohol more sterically hindered. Therefore it won't attack. Therefore this lone pair attack. So simply we can write this lone pair attack, Cl will leave. So simply we can write corresponding tertiary alcohol and here OTS. And we know that OTS is very good leaving group than halogens also. Now it is treated with the sodium azide, Na plus and N3 minus. N3 minus is strong nucleophile. Therefore it undergo SN2 reaction. The strong nucleophile attack, OTS will leave, Finally, we get our corresponding azide group and tertiary alcohol. So tertiary alcohol treated with the Lucas reagent conc HCl and ZnCl2, it follow SN1 mechanism, loses H2O, C plus will form, loses H2O, C plus will form, and the C plus react with chlorine. So this product is insoluble. This product is insoluble in Lucas reagent. Lucas reagent. That's why it is called turbidity. And because of the tertiary carbocation, the reaction takes place immediately. So this is our final compound, and it is after Lucas reagent. The reactant has two alkene groups and one epoxide group. It is treated with H plus and H2O or H plus heat. Only H plus is given, therefore H plus heat. So here what happens? Lone pair attract the proton. Generally in these cases, epoxide try to first react. Now here alkene is the nucleophile, so alkene attack, ring opening takes place. So carbocation is formed. Of course, we expect another possibility also. Alkene attack, ring opening takes place. Suppose if I consider next possibility also. Form corresponding carbocation like this. Now this alkene again react with corresponding C plus. Finally, we get corresponding carbocation here. Now it undergo elimination. Finally, we get corresponding. It undergo elimination. Finally, we get corresponding alkene. Stable alkene will form. Suppose it is participating in the reaction. It gives corresponding carbocation like this. It undergo elimination. It undergo elimination and form corresponding alkene. Now the product decolorize bromine water because of double bond. It decolorizes bromine water. Fruity smell with acid. So fruity smell with acid means when alcohol treated with the carboxylic acid, lone pair attack, leaving group will leave in the presence of acidic medium. It is what we call Fischer esterification, and the ester what we are getting, it is having generally fruity smell, sweet smell, fruity smell, sweet smell. So here it is alcohol, alkene and alcohol. It is for alkene test, it is for alcohol. Here also alkene and alcohol. So both products are possible. But PCC, so if I add PCC, it is a tertiary alcohol. We know that tertiary alcohol, no oxidation. But if I add PCC here, it is a secondary alcohol. Secondary alcohol undergo oxidation. Secondary alcohol undergo oxidation and form corresponding ketone. Form corresponding ketone. Now the ketone treated with, the product treated with Bayer's reagent. Bayer's reagent is cold alkaline KMnO4. Bayer's reagent is cold alkaline KMnO4. It is a syn hydroxylation. It is a syn hydroxylation, and KMnO4 will be converted to MnO2, it is a brown PPT. Brown PPT. It is a syn hydroxylation. KMnO4 will be converted to MnO2 and alkene part will be converted into, because of oxidation, alkene part will be converted into diol, vicinal diol. So if I consider stereo, we have to write syn hydroxylation. Above the plane OH, and another compound below the plane OH. It is our final compound. The reactant is pyruvic acid. The reactant is pyruvic acid. Pyruvic acid. When it is treated with NH4CN, NH4CN means ammonia plus HCN. So here we have to take ammonia excess. So for one possibility, acid base reaction, NH4 plus and HCN. And we know that ketone react with ammonia in the presence of H plus. Ketone react with ammonia in the presence of H plus and form corresponding double bond NH, imine. And this imine react with HCN, H plus and Cn minus. So nucleophilic addition. And finally the corresponding product is COO minus, NH2 and Cn. It is our final product. Okay, so here for sequence, don't consider ammonium cyanide, please consider ammonia. Please consider ammonia. So if I add ammonia, it forms corresponding salt. Ammonium salt will form. Now excess of ammonia react with ketone and form corresponding imine. It is our first product. If I consider acidification grantedly, it is our answer. So here please consider ammonia. Now it is treated with H2 and PT. It is a catalytic hydrogenation, and we know that in the catalytic hydrogenation, carboxylic acid, ester, amide and epoxide, these functional groups cannot be reduced generally. Therefore imine undergo reduction and form corresponding alpha amino acid. Now it is treated with ninhydrin. So it is a structure of ninhydrin. When ninhydrin treated with alpha amino acid, so this CO2 decarboxylation and this carbon undergo oxidation. Suppose this carbon is labeled as star. Answer CH3, CH double bond O, labeled carbon. So this part here, and the nitrogen part visible in the compound, in this compound. So nitrogen we can see here. So it is our final compound. So here nitrogen. So this nitrogen you can see here. It is having purple color, and also it is a Reumann purple. So this ninhydrin is test for alpha amino acids. Because of the color formation, this ninhydrin can be used for testing of alpha amino acids. It is what we call ninhydrin test. The reactant is CCl3CHO. It is called chloral. It is treated with chlorobenzene in the presence of H2SO4. So it is aromatic compound, and here by breaking the pi bond, by shifting the pi bond, we can create electrophile. Therefore it is electrophilic aromatic substitution. Therefore the chlorobenzene undergo electrophilic aromatic substitution. So this is our electrophile. By shifting the pi bond, this carbon get positive and this electrophile attack on the benzene. But here, because of alcohol group, again it react with another molecule of chlorobenzene. Another molecule of chlorobenzene in the presence of H plus, it loses H2O, C plus will form, and this electrophile again attack on the benzene. This electrophile again attack on the benzene. So it is a corresponding product. Now it is treated with silver powder. Now it is treated with silver powder. So in the previous classes we have seen one reaction when chloroform treated with silver powder, it reacts with 6 moles of AgCl, 6 moles of silver powder, and it loses AgCl like Wurtz reaction and form corresponding alkyne. Similarly in this case also, this carbon having the 3 chlorine atoms, therefore Wurtz reaction, type reaction. So it is simply Wurtz type reaction. It is a first compound and it is a second compound. Now it is treated with the magnesium. It is treated with magnesium followed by methanol. And here alkyne group is there, alkyl halide. And alkyne group with magnesium, no reaction, but magnesium can react with alkyl chloride. For example, PHCl treated with magnesium, it gives Grignard reagent, pH minus MgCl plus. Now it react with methanol. So pH minus attract the proton from methanol and form corresponding benzene plus methoxide. So Grignard reagent, we have to see always acid base reaction first. So the chlorobenzene converted to benzene. Similarly here chlorine, here chlorine, here chlorine, and here chlorine. So these 4 parts converts into Grignard reagent like this. After addition of methanol converts into corresponding benzene like this. Therefore the product can be written like this. Here hydrogen coming from methanol, here hydrogen coming from methanol, here hydrogen coming from methanol, and here hydrogen coming from methanol. So this is our product. Now what about remaining information? Decolorizes bromine water. Yes, because of alkyne decolorize bromine water. Negative test with the Tollens reagent and CuCl NH4OH. We know that if alkyne is terminal, when it is treated with AgNO3 and NH4OH, Tollens reagent, the acidic proton replaced by Ag, and it is a white PPT. It is a white PPT. It is simply acid base reaction. It is acid, it is base. So this is cannot be called Tollens test. So this is not Tollens test. It react with the Tollens reagent, but it is not Tollens test because Tollens test is redox reaction. Tollens test is redox reaction, and Tollens test also known as silver mirror test. So this cannot be called Tollens test, but it react with the Tollens reagent. So it is a test for terminal alkyne because internal alkyne do not give this kind of reaction. Similarly, terminal alkyne When treated with CuCl and NH4OH, in the presence of base, it loses proton. Cu plus form corresponding red PPT. Cu plus form corresponding red PPT. So these two are test for terminal alkyne. Since it is internal alkyne, it is a negative test. Since it is internal alkyne, it is a negative test. So here HNO3 and H2SO4 produces electrophile NO2 plus. Electrophile NO2 plus. So here two rings are there. One is pyridine ring, one is benzene ring. So if I compare rate of EAS, pyrrole more reactive than furan, more reactive than thiophene, more reactive than benzene, more reactive than pyridine. So benzene is more reactive than pyridine towards electrophilic aromatic substitution. Now position. Suppose electrophile attack at this position. This carbon get positive. So because of resonance positive, and of course here also positive and here also positive. So these are the carbocation intermediates. Suppose electrophile attack at meta position. After attacking electrophile here positive charge, and here positive charge. So if you compare here, if electrophile attack at ortho or para, you are getting more number of carbocations. That means more stability for the carbocation, and here less stability for carbocation. That's why the attacking position is this one, and this one. And we know that generally we consider para position. Therefore corresponding answer is para position NO2. Now it is treated with reducing agent FeHCl. We can also use zinc HCl, SnHCl and H2PD in ethanol solvent. Among these, the best reagent is FeHCl, because when NO2 undergo reduction, Fe undergo oxidation, FeCl2 will form, and this FeCl2 undergo hydrolysis, form ferrous hydroxide plus HCl, and this HCl can be reused. So it is an advantage. That means the ferrous chloride can be hydrolyzed easily, but zinc and Sn do not undergo hydrolysis easily. Now the product is, after reduction, NO2 group converted to NH2. Now we are adding Br2 in acidic medium. When you are adding Br2 in acidic medium, we get electrophile Br plus. It is electrophile. We are having aromatic compound, so it is activated ring. It is activated because when compared to pyridine, benzene is more reactive. Therefore, benzene is more reactive towards electrophile. Now here NH2 group is there. So it is OP directing group and strongly activating group. With respect to this one, para position blocked, only ortho position left. Therefore, the corresponding electrophile majorly attack at ortho position. It is our final product. Now this product treated with the sodium. So this is a lysine extract. The question related to lysine extract. సో నెక్స్ట్ ఈ కండిషన్స్ ఏదైతే ఇచ్చారో మనకి ఇవన్నీ లైసిన్ ఎక్స్ట్రాక్ట్. సో ఇక్కడ మనకి నైట్రోజన్ ఉంది, బ్రోమిన్ ఉంది. సో నైట్రోజన్ ఉన్నప్పుడు సోడియం ప్లస్ కార్బన్ ప్లస్ నైట్రోజన్ రియాక్ట్ అయితే సోడియం సైనైడ్ ఫామ్ అవుద్ది, అండ్ సోడియం ప్లస్ బ్రోమిన్ రియాక్ట్ అయితే కరస్పాండింగ్ సోడియం బ్రోమైడ్ ఫామ్ అవుద్ది. సో హియర్ వీ కెన్ సే ఫ్యూజింగ్. సో in question it should be mentioned as fusing. So when we fused, it form corresponding Lessane extract. So the Lessane extract contains sodium cyanide and sodium bromide, and Lessane extract is generally basic in nature. Lessane extract generally basic in nature. It is a Lessane's extract. Lessane's extract. Now this Lessane extract treated with FeSO4. When it is treated with FeSO4 in the presence of H2SO4, this Fe plus 2 form complex with Cn minus, form FeCN6 4 minus. FeCN6 4 minus. During the process, some amount of iron undergo oxidation, aerial oxidation, form Fe plus 3. Form Fe plus 3. And here Fe plus 3 and here complex. Finally, it forms corresponding Fe4, FeCN6 3. It is ferric ferrocyanide. Ferric ferrocyanide, and it is a Prussian blue. It is a Prussian blue. Ferric ferrocyanide. Now the Lessane extract treated with AgNO3 and acidic medium. We are adding acidic medium because Lessane extract is basic. To neutralize this one, we are adding HNO3. Now when we are adding AgNO3, AgNO3 react with NaBr. AgNO3 react with NaBr, form LOPPT, light LOPPT, AgBr, silver bromide. It is a light LOPPT, silver bromide. Now when we add ammonia, it is partially soluble. When we add ammonia, it is partially soluble. So it is a Lessane extract. So one is test for nitrogen, one is test for halogen. For test for nitrogen, cyanide formation is compulsory. That means carbon is compulsory.